Good day, guys. Darian Giuseppe here, back again with another video for the Key Concept series. In this video, we are going to look at a Module 2 past paper question for Pure Maths Unit 2. This question is based off of the topic of sequences, so let's get into it. So the question says that a sequence, and it gives us the sequence is given by the little curly brackets, T subscript n is defined by a recurrence relationship. What is the recurrence relationship? This guy over here is the recurrence relationship. And we have also to that T1 is equal to 11 for all n is an element of the set of natural numbers. Okay, cool. So that's what the question gave us. It gave us these two things here. Nice. It then proceeds to ask us in part 1 to determine T2, T3, and T4. So how are we going to do this? The first thing I like to do with any question like sequences or any question in general is write down the information that the question gave me. So that's what I will do first. Let's write down the recurrence relationship and the value of T1. So that's what we have here. So now we have to find T2. So what I'm thinking is T2, how can we find T2 using the recurrence relationship? I am thinking, let's let n equal to 1. When we let n equal to 1, this will turn to T2. This will be T1. And, well, we know what is T1. It's 11. So we could just substitute 11 here. And 11 plus 5 should be 16. And that is how we would get T2. And we could do the same for T3 and T4. So let's look at T2 first. So T2 would be equal to T1 plus 5. And we know T1 is 11 here. It was given. And we will get 16 for T1. So now let's look at T2. What T2 would be? I mean, not T2. We just found T2, right? So now let's look at T3. So T3 can be found when n is equal to 2. When n is equal to 2. So what will happen is T3 would be equal to T2 plus 5. But we know what is T2? It's 16. So let's just substitute the 16 for T2 and that will help us to get the value of T3. So T3 is 21. 16 plus 5 is 21. And then lastly, T4, to get T4, you substitute n is equal to 3. And that would give you T4 is equal to T3 plus 5. And we know what is T3. T3 is 21, so you substitute 21 here. So you would have 21 plus 5 is 26. And that's it there. And then you just round it up, tie up the whole question by just saying, therefore, T1 is 16, T2 is 21, and T4 is 26. So you're good here. That's the first part of the question. So now let's look at the second part of the question. It says, express Tn in terms of n. So how will we do this? They want to find a formula in terms of n for Tn. So the first thing I want to do, or I would like to do, is actually write down the terms. Remember, we have terms, right? We have, for this sequence, we have terms. We have T1. We just found T2 and T3 and T4. So let's write it down and see if any pattern develops, or we notice a pattern developing amongst the 4 terms that we have for this sequence. So this is what we have here in terms of the 4 terms. If you look at them closely, you would notice the difference between these two is 5. The difference between these two here is 5 as well. And the difference between these two is also 5. So the difference between T1 and T2 is 5. T2 and T3 is 5. And T3 and T4 is 5. So that's what we have there. And if you could recall, right, this sequence, it is exhibiting features of an arithmetic progression where there is a common difference of 5. Your first term would be 11. So if you could recall, the nth term of an arithmetic progression is given by t subscript n is equal to a plus n minus 1 by d. So I am thinking we could probably apply this formula here to get our expression, right, in terms of n. That is what I'm thinking. So let's try that. We know, let me just go back here. We know d would be equal to 5 and a would be 11. So that's what we would be substituting into the dance here, right? So this is what we would get here for our Tn. Tn is equal to 11 plus n minus 1 by d. Right? This is your first term. This is your common difference. So the next thing to do is just reduce this, boil them down like bhaji. And when we do that, we get Tn is equal to 6 plus 5n. And we can just tie up everything by saying, therefore, Tn is equal to 6 plus 5n. So there we have it, guys, the solution to part 1 and part 2 for this particular past paper question. I hope this question was clear to you all in terms of the explanation and the solution, the run through. Like the video, guys, share it to a friend, and subscribe to the channel